All right, we're live. So, neutralization reactions, mixing an acid and a base. Usually, it yields salt and water. That's because the acidic proton combines with the hydroxide to produce water, and then the metal ion and the acid anion combine to produce just an ionic compound, a salt. Now, you can get multiprotic or polyprotic acids. You can also get multiple hydroxides on your base. So this is more generally how it's written. You're going to have to balance these things. You're going to have to get the appropriate numbers of metals with the appropriate number of your anion, and you're going to have to get the appropriate amount of water. But by this point, you should be pretty good both at getting the proper ratio for your salt and for balancing reactions more generally. So hopefully this won't present too much of a challenge for you. Now, I say that it usually produces a salt and water, but the exception is ammonia, because ammonia doesn't have a hydroxide in it. It is still a base. It will still neutralize an acid. But because it doesn't have the hydroxide, you won't get water. You'll just get a salt out of it. So, for example, hydrochloric acid plus ammonia, when you neutralize, you get ammonium chloride. Sulfuric acid plus ammonia, you'll notice you need two ammonias to neutralize the two acidic protons. The result is going to be ammonium sulfate, okay, with 2 ammonium for every 1 sulfate. So again, there's nothing too exceptionally new here, especially since what we can get out of this is, writing out and balancing our acid-base neutralization reactions. And we can get net ionic equations in the exact same way. So go ahead, write these out, predict the products, and get the net ionic equation. I'll see you in a few minutes. Okay, welcome back. So let's go ahead and work through these. Chloric acid and barium hydroxide.
HCnO3O2 plus BaOH2O2.
All right, just swap partners. It's very much like a whatchamthing. We're going to need 2 of these. So we're going to make 2 water, liquid, and we're going to make barium chlorate, which is also going to be aqueous, because chlorate is usually soluble. Okay, so when we write this out, we break everything up into ions except for water. So 2H plus 2ClO3 minus plus Ba2 plus 2OH minus 2H2O, liquid, doesn't get broken up, plus Ba2 plus 2ClO3 minus, meaning that our barium and our chlorate are both spectators. They do not do anything. They're just there to bring the acid and the base, the noise and the sound and the fury, the funk and the funny hats. All right, so that means 2H plus 2OH minus yields 2H2O, which means technically the actual balanced reaction, net ionic reaction, should probably be this. But honestly, they don't ever actually ask you to do net ionic equations for these guys, for the simple reason that it's always this. So next up we have NaOH plus HNO3 yields NaNO3 plus H2O. So we're just swapping partners, and one of the products is going to be water, one of the products is going to be a salt. So aqueous, liquid. Okay, so like I said, I'm not going to do the net ionic equation for this. It is just too straightforward. It's just going to be H plus OH minus by H2O. And finally, NH3 plus HiO3 makes NH4IO3. There's no OH, so you're not going to make water on this one. But this guy is still aqueous. And this one I will go ahead and do the net ionic equation, because there's an interesting thing here. NH3 plus H plus IO3 minus produces NH4 plus IO3 minus. So this is just an interesting case because only one spectator ion, NH3, is taking that acidic proton to make NH4 plus. And it still stays in solution. It doesn't precipitate out, but there is a change. There is a reaction there. You have neutralized the acid in the base, but you haven't made it precipitate. Generally, acid-base reactions aren't as exciting as they're made out to be on TV. You do have to be careful because they will produce heat, and if you're dealing with really concentrated acids and bases, you could actually boil the water, and then you'd get spots, splashes, and that would be bad. But you're not going to get an explosion. Okay? But do be careful handling concentrated acids and bases. You could get hurt. You wouldn't blow up a building. All right, so that should be, yep, that is that for neutralization reactions. Those are fairly simple, fairly straightforward, not adding anything new. With that, we are done with this set of slides. There's a reason I pushed through, and it's because I already had these 4 done, which means next weekend I can focus on other things. We'll see what we can get to in class.